Hello and welcome to the Block Explorer. I'm Colin Brightfield.
Hey folks, I'm Cash Upton.
The Block Explorer is here to educate and inspire you about the world of crypto and NFTs.
We'll do deep dives into critical concepts for understanding what's happening and discuss current events shaping the space.
We're making this podcast for the curious, the free thinkers, and the change makers that propel us forward.
As we embark on our adventures, remember that none of this is financial advice, and crypto can be risky.
In this episode, we give you an in-depth look at the modular aspects of the Ethereum blockchain, and then we explore how proof of stake, sharding, and rollups enabled a modular blockchain design versus monolithic blockchains, which try to do everything on the same space and the same blockchain. And this is going to help you understand kind of the long-term thesis that we have for where the blockchain industry is going, where crypto is going, and the evolution of Ethereum in a really long-term view.
I'm really excited for this episode today. We both actually been reading the book written by Camilo Russo, The Infinite Machine, which goes over the history of Ethereum. And it's really cool to see the starting mission of Ethereum and how 5 years later, it's continuing to progress to get to the state that it was brainchild in and what it was thought up in.
Yeah, it's amazing to see the progression and Ethereum gets it done. Like the community builds and keeps growing and keeps evolving, they continue to iterate on this project of Ethereum. And it's just cool to see, the progression it's gone through, and also to see, how it's still, being built. It's still not done. And it is amazing, really inspiring and intelligent people that are building this great network that we love called Ethereum, as well as all these other blockchains in the space.
You gave me a link today. We're just listening to an auction by Sotheby's. And what was one of the forms of payment that you're able to use for Sotheby's auction?
In Sotheby's, on the official auctions, you can use ETH as a payment. They have it listed. So they have US dollars, they have euros, yen, won, etc. And then they also have ETH. And ETH has literally become cultural currency, and Sotheby's is signifying that by accepting that for their auctions.
So ETH is considered money by Sotheby's.
Definitely considered cultural significant money too.
I love it. And so what does this narrative look like then when we're talking about the different layers of Ethereum and the scalability of it leading to the soundness of that money principle?
Yeah, well, it kind of comes back to this whole narrative that's popular in crypto circles right now versus monolithic versus modular blockchain, right? And so that's kind of like the main theme of this episode. And we'll be comparing these blockchain designs. And this is important because the way that you build your blockchain is also going to kind of determine how the token is perceived and used, and ultimately, does it have monetary premium? And what we'll see here is that, the way that you design your blockchain is going to have significant impacts on the culture that can prosper or not prosper, depending on this blockchain design. And then that also comes down to, as an investor, where you want to put your money. You're going to want to pick the things that are going to ultimately win out, right? And so you want to understand this tech, not just from like a curious standpoint, which is fascinating, but it's also practical because it's okay. Like, well, if I want to approach the space and I do want to choose a proper investment, how do I compare and contrast how some of these things are built, right? We hear a lot of this narrative right now of all these layer one or ETH killers, like Solana, as you talked about a lot, or Polkadot, Cardano. People even talk about that one, Avalanche. So there's all these other blockchains that are layer ones that are coming out that people are saying, well, are they going to overtake Ethereum? And this episode is really just to explore, is that possible? How do they design their blockchains? How does Ethereum do it? And what do we see kind of coalescing and coming out the other end of the spectrum here?
And I think it's important to remind our listeners that currently Ethereum is more of a monolithic blockchain that is moving towards the modular with the different layers. And we can recommend our listeners listen to the last episode about the layers on the layers. But really, it's ETH's transition moment to a more modular blockchain.
Yeah, and Ethereum that's ultra scalable leads to ultrasound money. And you have more users, you have more transactions, you have more rewards for blockchain miners or validators. And so it just makes this positive feedback loop of the network's security is increased, which attracts more users, which creates more transactions, which creates more rewards. And so the network creates this flywheel that helps it scale. And also at the same time, if it's modular, you can keep it decentralized. So let's talk about some of the points that kind of set this argument, Cash.
Right. So the whole blockchain trilemma that we referenced in our last episode, which is the scalability of the blockchain, the decentralization of the blockchain, and the security. So the scalability is really directly related to how many transactions per second and the throughput of the system, whereas decentralization takes it to how many actual validators people, nodes are running that network. Is it centralized into the hands of 1 or 200, or is it spread across multiple thousands? And then security is just, how difficult is it to attack? Blockchains have been attacked in the past. Ethereum got attacked, called the Shanghai attack, was one of the biggest instances, and it survived. It never fully shut down. It was still operating, and it was able to do that because of a lot of the principles that we'll be talking about in this episode.
That's great, Cash. Thank you for that. And yeah, so the blockchain trilemma kind of forms this triangle, and it kind of demonstrates the trade-offs that you have to make from an engineering perspective when you design blockchains. And that if you want your blockchain to be fast, essentially, and scale to get a lot of transactions through, like something like Solana, then you're going to sacrifice on decentralization and security. If you want to prioritize decentralization and security, then you're gonna sacrifice some scalability here. And that's kind of the choice that like Bitcoin and Ethereum have done, is they've very much prioritized decentralization and security at the cost of scalability. These are kind of like, if you look at blockchains and how they're designed, they're kind of like really simple, computers that run over a network. And when you design it, these very kind of new kind of network computers, you have to choose how you're going to do it. And there's a trade-off here that you have to make.
And when they decide on that trade-off, it's either going to be usually 2 out of the 3 that they're picking, right?
Yeah, it's like you can't have all 3 kind of thing. Where if you focus on 2, then you're probably leaving out the other one. And it's kind of like you can't have your cake and eat it too when it comes to this. And some people, say that maybe there's a way to they wouldn't maybe agree, and they would say, no, there's a way to kind of have your cake and eat it too when it comes to this. But there's a lot of really smart people working on this, and right now the best solution is to have modular blockchains, and we're going to get more into exactly how that all plays out. But right now, what most blockchains do right now, they're monolithic blockchains. And so that means they do these aspects of a blockchain all on one layer. And the aspects of a blockchain are consensus, execution, and data availability. So Cash, what do those mean, and how do those relate to the blockchain? What's consensus, what's execution, and what's data availability?
So consensus is providing security because it's looking at the actual truth that's stored on the blockchain and comparing all the other nodes. Hey, is this content of this block correct? And they all come to a consensus that it is.
So they're all like
correct.
Checking each other, right? Essentially.
Right. Yeah, exactly. And let's remind our listeners, this is a proof of stake model, right? Is that what we're talking about? Because proof of work is slightly different than this.
Yeah, but either way, there's a consensus layer, whether it's proof of work or proof of stake. There's a consensus mechanism, and that's what makes it a blockchain, right? Where there's a bunch of other computers, a bunch of other nodes in the network checking on other nodes, and so it provides this agreement, right? Okay, I sent you 1 ETH. And so there's a bunch of nodes that are going to check my wallet address and say, oh, like, do you agree that Colin had 1 ETH in Colin's wallet? And then they're going to say, okay, and now we're going to all agree that now that 1 ETH that was in Colin's wallet, that token is now sent to Cash's wallet. And they're all going to now look at your wallet and agree, okay, plus 1 ETH to Cash's wallet. And so this solves the double spend problem, right? Which is like one of the major problems that you have with like when you create digital currencies that we couldn't, all the other projects that kind of were started before, they didn't have a way to create digital scarcity, right? You can just, because in the age of the internet prior to crypto, you could just copy pasta everything, right? Copy paste this, right click save this. Like we had Napster, we had torrents, like we all lived through that kind of stuff, right? So what consensus does is it creates actual digital scarcity through this mechanism where you're checking on each other. So you can't just copy paste another ETH, right? This whole crypto thing wouldn't work if I could just control click paste like just more ETH in my wallet, right?
Right.
Which
And
is
so,
kind of when you think about it though, it's kind of what the central bank does when they make more money. They're just kind of copy pasting dollars. So actually, like, it's like really twisted that we're the ones who are actually making digital scarcity and actual, what I would say is harder money, right? When you go back to Gersham's law, that hard money, easy, hard monies will will get removed from the system because everyone want to hold on to that and they'll just spend the soft money, right, which is dollars, right?
yeah.
Everyone holds on to their ETH, everyone's holding on to hodling their Bitcoin, their crypto, and then we get, if you go out to dinner, you're not spending your ETH, you're spending your dollars, you're because it's going to lose value, right? 6.1% in CPI last month.
Yeah,
So,
no, I mostly pay in dollars. I've paid for a few things in ETH, like our wonderful music production for the blockchain, the Block Explorer done by Mr. Matt Donner. I paid him in ETH, but not much else.
but that was for a crypto project, right?
Exactly,
So
exactly. I had to pay him in crypto. It was like
for crypto native things, it's cool.
Yeah.
I mean, but I know we both we don't like to part with our ETH, but you got to pay gas fees, you got to pay for
And so
NFT.
if I was sending you an ETH, it is the nodes have a consensus mechanism. They agree. And then the second aspect of a blockchain is the execution. So it's the actual computational power required to update the blockchain from that block to the next block. And the number of nodes on the system is what makes that, how much computing power that takes and how much, power is needed, right, to kind of can do the execution.
Yeah, so the execution is literally the processing of the blockchain of saying like I gave you 1 ETH. Like there's that has to happen. Actually, there's a computation done by the blockchain to make that happen. And then the last layer is data availability, right? And that's the storage layer. That's because a blockchain needs to keep a ledger, right? It's keeping track of everything that's happened on the blockchain. That's the whole point of it. So there's a storage of all the data that's been created before on chain. And this is important, right? Because this is the whole thing of a blockchain needs to be able to reference itself to check like, oh, Colin gave Cash 1 ETH already. So then if I try to send you another ETH, right, then it's like, oh, you don't have that ETH because we just checked and you already sent it. So that's like a really basic idea of it. So when you combine all three of these, you have a blockchain. We have consensus, execution, data availability. So we have the consensus is like the security mechanism, right? We all agree on something. And then the execution kind of maps to the scalability, right? Like how many transactions can you actually process per second? And then the data availability comes into, the scalability and the security and decentralization. All three kind of hits all three of those. But when you look at it, right, it's like a really basic trust computer, I think is a really great way to look at it. Blockchains are just really crappy computers, but they're really good at providing trust. They're just really good at one thing. They're not good at being fast. They're not good at storing a lot of data. They're this network. There's just like this really primitive computer that lives virtually on the internet. And most computers, like what we have at home, right? They do storage and they do execution, right? You can play your music, you can play your MP3s, you can play your videos. And a lot of times now we don't even have that much storage because it's all in the cloud, right? But it's just mostly execution, right? But then execution, right, is actually like computing stuff. So that's like your normal PC at home is your phone is like that's your phone execution and data. But what a blockchain does, it makes it different. It's what makes it special is the consensus layer, is this trust layer that it adds through this network of nodes of everyone else checking everyone else to make sure whatever they're saying is true, whatever data they're transmitting from their computer is correct and can be verified.
And that's what makes it so valuable to get onto the ledger, to get onto the blockchain.
Yeah, exactly. And so when you have something like Ethereum has prioritized decentralization and security and not scalability, right? So Ethereum's great at consensus, but it's not that good at execution and data availability, right? So there's layers that have been those layers are ideally going to be outsourced, whereas monolithic chains, right? They try to do everything at one layer, everything at once. So Solana, it tries to do consensus, execution, and data all at one layer, all at once. And it's maybe because they're doing that, right? They're sacrificing for scalability. They're sacrificing decentralization and security.
And currently, Ethereum is a monolithic, which is being built out before our eyes into different modular aspects to then be able to essentially take a bunch of data that people want to put onto the blockchain and put it into a layer 2 mechanism, a roll up or a shard or something we're going to get into a little bit later, and then put all that onto layer 1 at a much more efficient method.
Yeah. So the modular approach kind of allows this specialization to develop naturally, where you can have a group of people over here working on the scalability solution, right? And they're making layer 2s and they're making, roll-ups and things like that. And then you can have another group of people who are making different solutions for execution and ways to get more transactions through. And then you have another group of people that are in the data camp, and their teams are working on how to store data on chain and how to make it available in a smooth, quick way.
And then, so where does this kind of progress us when we're looking at different types of chains and how they make use of blockchain space?
Yeah, so blockchains kind of progress in 3 stages. And there's a great pseudonymous poster on Twitter, Polynaya, and they have a great thread. They're a really smart person. So if you want to learn more about this, check them out on Twitter. It's POLYNYA. And they say that in a type 1 chain, you have individuals buying block space. In a type 2 chain, you have applications that are buying the block space. And in a type 3 chain, you have other chains that are buying the block space. And it's remember that blockchains sell block space before we get too far in the weeds. That's the product, right? Ethereum sells block space. Solana sells block space. If a blockchain's fees are really cheap, that's because they don't have that much demand for their block space. The demand for Ethereum's block space is really high, so it has higher fees.
Right. And those fees aren't just paying for a transaction necessarily. They're also providing a moment in time, a snapshot to get you onto that blockchain. You're now on that immutable ledger with that transaction, with that NFT, with that DeFi, with whatever you're doing. you just paid to be immortalized into that moment of time in that block space.
Yeah, that moment is yours for forever on that blockchain. That's just it's immutable. It can't be changed. It's done.
So how would you relate Ethereum to the Polynia scale?
Well, right now, we're in kind of a type one because you have people buying block space, individuals. But then, it's also, we have, we're kind of in mixture. It's kind of in transition, right? Because then you also have type two. You do have you have a lot of applications that are buying block space to get functions through. And then, when you roll up to the layer two conversation, when we referenced in our previous episode, you have this layer of layer two blockchains that are going to sit on top of Ethereum, and then those chains are going to be interacting with Ethereum, and they'll be buying block space. So what you're seeing though is an evolution, and we're kind of like in this kind of migration. I think a lot of people are that might use Ethereum are kind of still in the type one phase, but we're going to eventually, a lot of people are going to be interacting kind of more in the type three phase, or they're going to be on layer twos, and then they'll be using a blockchain that sits on top of Ethereum, and then that blockchain will buy block space on behalf of them through their transactions on the layer two.
And we'll get into a little bit more of the nitty gritty later in the episode about how exactly that layer two interacts with the layer one. But I kind of want to bring back the question of decentralization just to give our listeners like a little bit of context. What are we talking about in terms of Bitcoin, Ethereum, and Solana, being the top three that people are really listening to right now in terms of decentralization?
Yeah, I mean, I want to back up before we get into that is, just what is decentralization? Because I think, it's a really hard thing to define in crypto, and a lot of people will just throw decentralization term around really loosely, and it's also kind of a term that people use to kind of just like throw shade on different projects. So like, oh, it's not decentralized enough, blah, 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 but they don't really define it. And so, and I think it's really hard to define, but it definitely has like a spectrum, and, there's different ends of the spectrum. And when you can think about it, like, okay, or something that's super centralized is like a centralized tech company that's run, by like a founder, like Facebook is pretty centralized, right? As far as decision making goes, right? As far as where the power goes, or if you look at like a monarchy, right? Or you look at like a dictatorship, anywhere you have all the power, where a few people hold all the keys, and they can kind of choose whatever they want to do. Right. That's centralization. And also it leads to, an easy to corrupt situation, because you only need to convince 10 people or 5 people to do something, and then then it's done. And so decentralization is, how much can you spread out the risk of corruption? How well can you spread out and distribute the power of governance? And that's a hard nut to crack, and there's different answers for different use cases, right? But so Bitcoin, right, prides itself on like, being really secure, and so it's one of the most decentralized networks in blockchains. And according to BitNodes, right now they have approximately like 13,000 nodes that are showing up. Ethereum is really interesting because you have these pools of nodes, right? You need 32 ETH to run a node in Ethereum. This is an interesting thing too to point out. Like Bitcoin, there's 13,000 nodes, but you need to have special hardware, right? You need to have special processors, GPUs. So like a lot of them are like the ASICs, right? And there's an investment up front before you can even start running a node for Bitcoin.
Right. And that's the proof of work, which takes the massive computing power.
Yeah, because you're competing to solve a really complex math problem with everyone else. And if your mining operation, your node is able to crack that puzzle fastest, then you're rewarded with a Bitcoin, right? That's how the whole Bitcoin mining thing works. And that's how they secure their network, because you're doing these crazy puzzles in a way that shows that that verifies the ledger.
And then we have Ethereum, which is doing a transitional period to proof of stake pretty soon. And can you just give us a quick rundown on how that differs from the proof of work?
Yeah. So well, Ethereum, they have a pool of nodes, and you need 32 ETH to run a node, but you can run it on your own PC at home, and so you don't need any special hardware. And yeah, the proof of stake is interesting because it uses a lot less energy. So that's one thing that people need to understand. It uses about 99.97% less energy than proof of work, because instead of solving a problem, you're taking your 32 ETH and you're staking it, which means that you're depositing it into um, a almost like a bank account, right? It's like a vault that holds onto that 32 ETH, and you're saying, I promise to check all the transactions and not do some weird things that are corrupting the network. And by promising that, I have my 32 ETH staked, deposited to kind of back up my word, right? And then if you do something shady, then the protocol will automatically just take your ETH. And it's called slashing. And so you get like there's a punishment, right? There's an immediate punishment for if you don't, and if there's a reward, right? So it's like this, like, and so it has people who are most committed to committed to Ethereum be the ones validating it, which is kind of makes it really secure, right? Because the people who believe, if you have 32 ETH, right, that's what ETH is at, like 4,000 right now. So like 32 ETH, that's more than $100,000. It's like 120 grand. So, if you're going to put $120,000 at stake, you're going to probably, care about the network. And so you're least likely, you're not going to, it's kind of this self-selection thing where you're not really going to get people who have malicious intent to really kind of risk that much on a regular basis. So it does kind of do that. And then there's a pool of nodes, right? So the nodes can switch too. And then we have Solana, which they have emphasized scalability, right? So they have less nodes, which allows it to be a little faster. And they have about 200 nodes. And it's on like a different end of the spectrum, right? Where it's fast, the fees are low, but there's less nodes. So it's more centralized. So it falls a little different part of the spectrum than some of these other blockchains.
And the reason why we're bringing up how many nodes is because if someone did want to attack the network, they would have to convince a certain number of the nodes to collude with them on changing the ledger to then cause an attack or say, no, I actually have 100,000 ETH in my account. What are you talking about?
Yeah. And they call that a lot of times a 51% attack, where you need to convince 51% of the validating nodes in a network to go along with your plot, right? And the social coordination aspect of doing that, when you consider that the nodes are spread out all across the world in different time zones, and you probably don't know them, right? You don't know them personally. So there's a social coordination element, and then there's also the financial element too, where you have to convince them that they're going to make more money back in that process than losing their 32 ETH or whatever it could be, losing what they have at stake there.
Right. So 51% attack on, you said Ethereum had 1,300 nodes. So if you had to convince 650 Ethereum nodes at 32 ETH times $4,000, that's like $83 million to even try to get people to start thinking about attacking.
That's their break even, though. That's their break even.
Right.
So you have to convince 650 nodes, and then that they're going to make more than 32 ETH, in that. Yeah. So it just, it gets to this point where it just becomes, it's not impossible, right? There is definitely a greater than zero chance of it happening, but it's just really, really, really low. And that's really like, when it comes down to like a lot of this cybersecurity stuff, is that the experts will tell you is that nothing is 100% secure. If someone tells you that, they're lying to you, right? There's always some risk and some vulnerabilities in these systems. The goal is to reduce it to the smallest amount possible. And that's what the design of Ethereum has done with the decentralization. That's what Bitcoin has done with decentralization. And that's why these are like the most highest market cap assets in the space, because people trust the networks. They've created a network of trust. And that's when you think about blockchains. They're networks of trust. And not all of them are as trustworthy as you might think. And that's why it's good to have this conversation and to just explore these design trade-offs that people make when they design these blockchains, and understand how they work, so that you can be smart when you decide to invest.
Yeah, because at the end of the day, you're using different blockchains for different things, right? So Solana is really great at what we just talked about, quickness, transactions per second, maybe for your gaming experience and music, and certain other applications. It's a really great network. But if you have, $500,000 in decentralized finance that you want to run on a protocol, maybe you choose something a little bit more secure and decentralized.
Yeah, that's a great point, Cash, that different blockchains have different design emphasis for different reasons, right? Some of them, they need a fast throughput because they have games running on the back end. So like Axie Infinity, right? Like you can't have a game like Axie Infinity on the Ethereum blockchain, because every time you do something in the game, you can't be paying $100 in gas fees. And just like no one would play the game, right? You just can't do it. So there's different solutions for different use cases. And that's what you have to remember, Ryan, too. It's not a one size fits all world. This is all evolving in an ecosystem. And this design with Ethereum is one way that, like we said, is it's emphasizing security. So if you need a game and you need things to be fast and cheap, then that's why they have the Ronin side chain for Axie Infinity. They actually have their own blockchain that it runs on, so it can be super fast and get things done for the game to run.
And then Ronin publishes on top of Solana.
No, Ronin connects with Ethereum.
Oh, right. Okay. Yeah, that's right. Axie is on Ethereum, huh?
Yeah.
Okay. So Ethereum has the security and the decentralization. And so getting back to this modular design, what are the modular mechanisms that's allowing for the scalability of Ethereum?
Yeah. So we have a few different things that are cool. We have these things called rollups, which is like a zip file where you just kind of compress everything down and a bunch of transactions down, and then just send that one hash to the layer one, and so it reduces your fees. It's like carpooling, right? Like you can just, everyone gets in the same car and you go to the same place instead of all driving separately. So you save money on gas, right? And that's what you save money on the layer one. You save money on gas. So like carpooling is a great mental model for what rollups are. You still get where you're going, but you pay a lot less, and sometimes it's more fun too, right? Because you hang out with your friends.
I love it. And then the next aspect of modular blockchains is sharding, which this is providing more data availability.
Yeah, so shards are literally what they sound like, right? They're shards of the network. So the shards are like little slices of the network that you can break off. Different nodes can kind of have different versions in these shards, and it allows you to scale the data, so you can store more things on these blockchains, but it doesn't have to essentially be stored on the layer one. All that data doesn't have to necessarily need to be sent to the layer one to be processed. It can sit on these layer twos, on these shards, and then they can access that data when needed. But it doesn't have to kind of sit in the middle of the intersection and clog things down.
And then essentially what we're seeing right now with Ethereum,
shards are kind of like it's almost like storing your stuff on the cloud on your phone, right? Like you could have all your photo, have like sometimes, phones have a lot of data now, but there was a time when you had your iPhone, maybe you were like had so many pictures or something, or so many apps or so many like playlists or whatever downloaded, and your phone's like, okay, you got to like delete some stuff. And like Apple lets you like upload it to the cloud, right? You could like store on iCloud. And that's kind of like what sharding does. It kind of lets you store data on a blockchain, kind of almost like cloud. And so you can still have all the benefits of having certain data on chain, right? Because we want certain data to be on chain that's the whole idea of the blockchain, that it's this ecosystem, and it has to confer with the data that's on it. It needs to be able to check things, but it can be cumbersome, right? To have all this kind of stuff sitting on the layer one. So that's what the shards do.
And with the different like designs of sharding and rollups, some of them take less time to process than others, right? Like there's a few different rollup mechanisms like optimism or ZK, zero knowledge, ZK. And some of those can be done a lot quicker and some maybe take a few days, but maybe you're okay with that time period.
A few days is too long in crypto,
right?
Like there's a whole DAO will be spun up to buy the constitution by the time your transaction processes.
Yeah, you bought into that DAO, didn't you?
Yeah. I mean, live free or die.
Okay, so what happens if a layer 2 breaks? What if your stuff's on a layer 2 and it doesn't? It has some error or some attack. Can you get off the layer 2?
Yeah, you can just go right back into a layer 1, right? Like there's a great comedian. I forget who he was, but he said
Mitch Hedberg.
Yeah, right. Sorry. Escalator
Elevator
temporarily stairs. It's like, well, you can still get where you're going.
I know. I hate it when they cordon off the broken escalator. It's like, hey, come on, those are still stairs. Let me go up it.
Right? It still works. It might take a little more effort, but you can still do it. So yeah, that's what's cool about layer 2s is that you with all this crypto revolution is that you own your assets, right? Your assets are yours, they're in your wallet. So you can go from layer to layer. You can take your assets with you. You might have you're going to have to pay like the bridging fee, right? Like the transaction fee. You have to go from, if you want to go from Ethereum to Optimism or to Arbitrum or wherever, there's a one-time bridging fee. Like you would pay a toll to go across like a bridge, like whatever it is, like the Golden Gate Bridge. So there's a toll. But then once you're there, you're there. So ultimately, and the layer 2s are really new. So yeah, there is a warning there too. Like if you are exploring some of these layer 2s, they're still kind of like in beta mode. So, just be smart.
Yeah, maybe don't move all your ETH to layer 2 right now.
But it's cool to explore. They are operational. There's apps on them. And they are getting more, there's more products and projects launching on them every day. And then I'm excited for the games that are coming on them too soon.
And what does this mean for like security? I know we went over this a little bit a few minutes ago in terms of like proof of stake and the consensus. But is there a modular aspect that kind of, makes security more when people might think it's a trade-off, but it's actually adding to the security of the network?
Yeah. So when you have more people so Ethereum is moving to proof of stake from proof of work. So right now it's kind of on the same mechanism that Bitcoin uses to create consensus. And we went over this, right? Proof of work, it's just solving a complex problem. Proof of stake is anyone who owns this native asset can deposit this native asset on the blockchain. And then that asset is kind of in this vault and held as kind of collateral for providing security. And so the biggest difference here is that like you no longer need to have a physical piece of hardware to be someone that can participate in network security. Proof of stake lets anyone who holds ETH to participate in the security of the network. And so that just this whole decentralization narrative just blows through the roof, right? Because now anyone can do it. So if you have some ETH and I have some ETH, and yes, 32 ETH is what you need is to kind of run your own node, but there's protocols and options that let you pool together your ETH, and Lido is one of them. There's a bunch of other ones, and you can pull your ETH together with a bunch of other people to create 32 ETH, and then you have a node together as a pooled validator, a pooled node. And this wins from a decentralization standpoint, in that anyone can do it, so it proliferates it more. And then as it becomes more decentralized, right, it becomes more secure, right? Because now it's harder and harder to corrupt when anyone can do it, or anyone in the world, it's going to be increasingly difficult to find a way to attack. And it also is better for the environment, and that we're not using all this energy to secure the network. And I know that's a huge narrative that people keep coming back to. And I think it's, that's one of the things we prioritize talking about that on this podcast, is that there's a lot of misinformation out there as far as the environmental impact of a lot of this technology. And one of the cool things is this proof of stake transition called the merge, that's going to be happening on the Ethereum blockchain next year, is going to minimize the power usage for the network.
Yeah, not only the power usage, but people are replacing their GPU ASIC processors, every few years to have the cutting edge technology to solve that proof of work problem the fastest. So that no longer becomes a wasteful industry in and of itself. And I think it's also important, some people might say, wow, 32 ETH, like $128,000. But what are we talking about when people are actually Bitcoin mining, or, putting together rigs to do that operation of mining? How much, are they spending?
They're spending a lot. I mean, because you're competing with everyone else who's trying to Bitcoin mine. And so if you actually want to have a viable chance of becoming the miner that mined that one block, you need to invest tens of millions of dollars, right? And that's what you see, these massive companies that buy these warehouses and just fill them up with computers and GPUs and servers. And they have, it takes a technical expertise. It takes, a considerable amount of capital to get into that, and be successful. And that does create centralization vectors, right? Because you do have some of these, there are centralized companies now that are the biggest Bitcoin miners, right? Whereas Ethereum, it can just be anyone that has some ETH.
Right.
So it's a much more decent. Yeah. So it's a much more it doesn't have the vector for Ethereum is to become more decentralized over time as ETH proliferates across, the globe. And the vector of Bitcoin is kind of tends to a more centralized vector, just because you have these centralized companies that are really profitable, and then they have more capital to invest in mining Bitcoin, and then they mine more Bitcoin, and then therefore they just have more money to mine more Bitcoin. And so there's a barrier to entry that's developed there that you don't have in some of these other architectures.
And you referenced the security of Bitcoin being the supply of the certain SHA hashes, which for our listeners is the secure hash algorithm. But could you just go into that a little bit more? Like, what does that mean in terms of like the supply of those hashes?
Yeah. So the ultimate supply of the security is based off of how much GPU power you have to compute these hashes, right? So there's a very complex problem for every transaction that gets sent to a Bitcoin ledger has a hash, and there's a puzzle that all these Bitcoin nodes have to solve to earn and mine the next block. And so essentially you could kind of deduce it down to the amount of security on the Bitcoin blockchain is the sum of all the hash power that the network has at any one point. And the fact that you can compute that down to this hash power, some people will criticize it, it's not as necessarily as a secure way to define, the decentralization of the network, because it like I said, it has these centralization vectors where it's like obviously centralized companies are controlled in a significant amount of hash power. Like you could look and I'm sure there's certain websites that show you, and you can kind of see wow, there's certain companies in the world have a significant amount of hash power that they can use to kind of sway the network. Gotcha. Essentially.
it's not just one guy in their basement with a rig of 10 GPUs. This is a huge warehouse with thousands of GPUs, and all that hash power is centralized into one.
Yeah, all the ones that got kicked out of China, right? Because China banned mining. So
Right.
they all left China, and they guess what? A lot of them are moving to Texas to start their operations because Texas has cheap energy and a lot of pro crypto rhetoric. So interesting. It's interesting. China said no, and Texas said yes.
Right. Hey, Lone Star, baby. So Bitcoin is that hash supply, whereas Ethereum, what you're referencing, it's
It's the
actually
ETH supply.
the supply of the actual native currency itself. It's ETH itself.
Yeah, so there's an interesting thing where Ethereum kind of folds back on itself with proof of stake, that the asset itself is what is used to secure the network, whereas hash power is what's used to secure Bitcoin's network.
I love it. So let's tie it all in. We were talking about ultra scalable Ethereum leading to ultra sound money. What does all this mean, for the inflationary principles of cryptocurrency, and specifically Ethereum, as it moves to this modular, ultra scalable solution?
Yeah, this is really important when it comes down to the whole money talk and the future of money. And I really want to tie it all together now here in this final little discussion here, back to first principles. Why we created this podcast, why we care about crypto, why we care about NFTs. It's this whole revolution in property rights and in value, and how we ascribe value in our culture, in our society. And the fact that the federal government can control money in a way that corrupts and doesn't always have positive impact on society is one of the things that crypto helps solve. Is that crypto puts the power back in the hands of you and me and everyone else to choose how they want to spend their money. It's your money. You worked hard for it. No one should be able to tell you what you can and can't do with your money. And furthermore, you should be able to spend it, and access it on a Sunday.
Well, and also spend what you earned, right?
Yeah.
And when the U.S. Treasury issues 40% more dollars, your buying power just went down pretty significantly.
Yeah, I mean, it's a hidden tax. So, go ahead.
Well, and a lot of our listeners, I think, are in the States, but it's good to remember that we have had a pretty steady inflationary trajectory over the last 2 or 3 decades. But, for all of our South American friends, there are places where overnight people saw their savings of, $100,000 just pretty much go into nothing because of 20-30% inflation, which is exactly why we want to educate people on the power of the blockchain to give power back in the hands of the middle class and the people who don't really have much, the people who don't even have access to a bank account.
Exactly. So the way that this works is that crypto economic networks pay their security providers via issuance and fees, and using the fee revenue to pay for security displaces the amount of issuance that's required. Right. So when you mine a block
as much. Sorry.
Yeah. So when you mine a block of Ethereum, then use a block reward of 2 ETH, but then there's also the fees, right, that are collected. And so if you're able to pay for more of the revenue with fees, then the more the fees the blockchain collects, the less it needs to inflate the supply of the currency, of the network, of the tokens through issuing tokens, right? So the block reward's 2 ETH, right? But if you go to like watchtheburn.com, right, you can see there's some deflationary blocks, right? There's more gas, more Ethereum is burned in the block to make the block process than is issued.
And this is because of EIP 1559, which is burning the fees. Not every blockchain burns their fees.
Exactly. Not every blockchain burns their fees. And this is one example of how the update that you mentioned, EIP 1559, which is an update to the Ethereum blockchain, and how it works. When you pay your transaction fees, they're not going to necessarily, not all of it is going to the miner, the validator. Some of it's being burned, and through this update. So when we say burn, it means it's just gone. It's sent to an address that just deletes it.
That's so cool. So what is this doing to the money principle of Ethereum, essentially?
Well, if you want your security to be cheap, then you can't just rely on transaction fees to pay for your security. You have to also rely on issuance, which creates kind of like this inflation, right? So if your block fees are aren't I don't know aren't raising enough money to kind of pay for the people providing security, then the way that you pay for security is you print more dollars, right? You create more tokens in the crypto way, right?
Gotcha.
You're issuing more tokens to pay for this security rather than having the fees, the revenue, right? It's like having a business where it's like one, you're taking out loans to pay your employees, and another one, you have a business and your business is actually making money, and that's how you can pay your employees. So one's a way healthier place to be in, right, than another.
Right. And so, like, for instance, Solana, everyone references for having really, really low fees, but that means there's not that many fees going to the people doing the consensus. So they're instead doing a lot more issuance of the Solana for that reference.
Yeah, so you're going to have to issue. Yeah, Solana has inflation, right? There's issuance inflation, there's token inflation for the Solana network because there's not enough fees being generated to cover their expenses for people to secure the network. So you kind of are in this weird thing where it's kind of like where um you're creating this. Essentially, it is inflation because there's more SOL entering the market than that's being deleted. Whereas Ethereum, that Solana, I mean that ETH is being burned.
Yeah, Polynia had a good breakdown of kind of issuance and fee relationships. So, for instance, on the Solana network, if it's collecting roughly, $10,000 a day in fees, but perhaps when it's really being bogged down because of all the speculative mania, maybe it's hitting $100,000 a day, which is about $36 million annualized. But Solana is giving out close to $4 billion in inflationary rewards of Solana. So that's almost a net loss of like 99.2%, which leads to the inflationary side.
Yeah, I mean, I think it's a really important point, and just to bring it back, kind of like bird's eye views, like blockchains are businesses, right? But the way that they work is right. They're supposed to be eventually, right? They're almost like trustless business where you don't really have a person, kind of running it, right? It's a computer code that's the business and it's running, and the way that you design your blockchain, the way that you kind of make your business is, they're selling block space, and they sell the block space with fees. And then the way they secure the network is like taking those fees and paying people who have a considerable interest in the blockchain to secure the blockchain. And so there's this cycle, right? And what Cashy, just the point you just made, is that not every blockchain solves this the same way. Polygon, for instance, is a POS sidechain for Ethereum. It has around $50,000 a day in transaction fees, $18 million a year annualized, but it's distributing over $400 million in inflationary rewards. So that's an incredible net loss of 95%, right? So that's not a great business model. and if you want your token value to increase, right? If you're inflating your currency at that rate, it's not going to do well for the appreciation of the value of the token. But Polygon, it's in this infant stage, and it's in the liquidity mining stage where they're kind of putting out tokens for people to use the network, and that's kind of why they have this big inflationary costs, and they know that, and people know that you can get token rewards for Polygon by using different apps, and so they reward you in Polygon for using things on the network, and that's why they have such a massive inflation. Then you mentioned Solana. Solana's very cheap fees, but they're also giving out an astounding amount in rewards as well.
So what this essentially means for an Ethereum type blockchain, which has larger fees, that large fee market is essentially, kind of incentivizing decentralization, because it's encouraging more people to put in their ETH and stake it because
Because
of.
if ETH is valuable, right, then it becomes more important, more, you know, incentivized to mine your own ETH to validate the network.
And then that kind of plays back into the inflationary, or disinflationary, principle of it.
Deflationary.
Deflationary. Thank you. I promise I got a poli sci econ degree.
Hey, I mean, I like disinflationary as well too. As long as it means the amount is going down, so the supply is going down. Hey, I'm good. I'm good.
Yeah.
Supply down, demand up. That's what we want. No, so yeah, we made a great point, right? So if the fees are strong, then you're limiting the amount of block space. You increase the decentralization by removing the hardware requirements. And then you see the fee revenues being captured by limiting the availability of block space. So that scarce block space creates high revenue fees, which generates a high amount of ETH burning, which makes ETH more scarce, making it more valuable, which makes more people want to mine it, etc. And so you kind of get into this positive flywheel where you have ETH as the asset, ETH as money, creating more incentive to secure ETH, the network, Ethereum, the network. And as ETH, the Ethereum, the network becomes more secure, here we are back at the beginning of the cycle. And now more people want to use it. It's more valuable. The block space is more valuable.
That's why we're bullish on ETH.
Yeah. So let's tie it all together. So if you have a constrained layer one that tries to do everything on a monolithic scale, right? Does consensus, does execution, does data storage. If it does everything all at once, right, you're kind of gonna run into the blockchain trilemma. You're gonna run into this trilemma. So the way that Ethereum has its design to solve this is by being modular, right? You have all these little pieces, and Ethereum's like, okay, I'm just going to do one thing really well, and that's going to be consensus. And then through this whole design, we're going to have more scalability and more decentralization.
Right. And we're seeing that greater availability through the sharding and the rollup processes, which are essentially allowing for more layer one block space, as a function of Ethereum security, which is growing and growing when more and more validators come onto the network.
Yeah. And then rollups create an unconstrained execution environment. So they bundle up the transactions, tiny packets of data, pull those all together and send them to the layer one for settlement. And as this architecture becomes built out over a wider surface area, you're going to have more and more layer twos that create this vibrant ecosystem of blockchains that are sitting on top of blockchains that interact with one another. And they're going to be super decentralized because you have so many of them. And because you have so many of them, also the possibilities for storage of different data is going to increase. And we're going to have gaming blockchains like Immutable X. We're going to have storage blockchains. We're going to have all these, it's really going to allow the kaleidoscope of projects and interests to actually happen on chain. And, there's no, it's impossible to think that we're going to be able to scale to the entire world on one layer one blockchain, right? It's just not a feasible thing, right? Just like it would be impossible to think that just like one company, right, would be enough to just run every power company in the whole, every power structure in the whole world. It just doesn't make sense. So, the decentralization thing is also how we really get to the adoption part and how we really bring this technology to make it accessible for everyone.
Yeah. And I love where you're tying it together. This is what makes Ethereum so decentralized and so secure and allows it to do X, Y, and Z. But again, like we referenced, Solana has its place in the world. Solana is really great for the throughput and the low fees. But we really want to remind our listeners, hey, what are we using different blockchains for, and what are they trying to solve, and keep that in mind when we're assigning value.
Yeah, we live in a multi-chain world, and there's going to be different solutions, and they all kind of fit together. I used to play with Legos as a child, and I kind of look at them like Legos, right? And you can get different Lego sets, but once you have them, right, no one's preventing you from taking sets from pieces from one set and then mixing with different pieces, right? And you can make your own. And that's what we're kind of moving to this world where you have blockchains like Legos that can build on top of each other. And you can take different blockchains that, you could take the set that was like the castle set, and you take the Harry Potter set and the space set, and they can like work together now, and you can interact. And because they can work together and interact is actually a benefit. The distribution of where the users are, where the power is a massive benefit for everyone, because it makes everything more secure. And we can use the internet in a completely different way as crypto native token holders, where we own our own data. We can move from chain to chain, so that it ultimately makes each chain have to behave in a way that is nicer to the users, because we have the power, not these big, huge tech companies that mine all our data and give us nothing.
Love it. And I direct our listeners back to The Infinite Machine by Camilo Russo, because it really does a cool explanation of why Ethereum was founded. And it goes straight to those decentralization principles of not giving all the power to where the power has been consolidated over the last, few decades.
Fantastic, Cash. That's a great book. Yeah. So if you haven't checked that out, check it out. And we're just going to finish up here with what are you excited about?
Oh, man. Well, I was really excited that you were participating in a DAO to buy the Constitution today.
I know, it was super exciting. Constitution DAO. We pooled together all of this ETH to making a bid on a copy of the Constitution that was on sale through Sotheby's today. But unfortunately, it did not succeed. But what did succeed was the demonstration to the world of how powerful DAOs are, because it was written up in it got all sorts of press. It was in the New York Times, it was on CNBC. As people are like, what's a DAO and why do they have $49 million and how are they trying to buy the Constitution? And like everyone that understood crypto was like, this is awesome. And everyone that didn't understand crypto was like, what the heck is going on?
Yeah, no, it was such a cool example of the coordination that can come through blockchain. And at the end of the day, like you said, it's bringing it all back down to the layer zero, which is people.
It's people all the way down when it comes down to it. So speaking of people, make sure that you get ready for our in real life NFT event, where we have people in person doing NFT stuff. When we're talking about NFTs, we're going to have an NFT auction with Chester Arnold, Manuel de Cisneros, and John Schooler. It's going to be amazing. It's happening in Santa Barbara on December 4th from 4 to 7 p.m. at the Soho Music Club. You can get more info at reliquarydao.com. That's spelled reliquarydao.com.
Yeah, I'm really excited for that. And folks, this is the blockchain. If you can't make it in person, you can still participate in the NFT auction.
Awesome. Well, we're going to wrap it up for here. Thank you for listening. We hope that you enjoyed this episode.
Yeah, thanks for exploring the world of blockchain with us.
Crypto is changing the world, and we're here to ensure that you are ready.
Please subscribe, share this podcast with your friends and coworkers, and please do leave us a review.
We look forward to sharing our next episode with you.
Salud.
Cheers.